Hi everyone, welcome to another episode. So this time I have decided to participate in October Leetcode challenge, and it basically lasts from 1st of October until the 31st of October, and every day they basically unlock one question for us to solve. I'm planning to be a regular in creating my videos and solving these problems on a daily basis. So let's look at today's question and try to knock it off. So you're given a recent counter class which counts the number of recent requests within a certain time frame. Implement the recent counter class. So basically we need to complete this class. So let's say if I select C++ as my preferred language, I get a template and I just need to complete this off. So it says recent counter initializes the counter with zero recent requests. Okay. And then there is a method int ping which takes in one argument, time t, which represents time in milliseconds and returns the number of requests that has happened in the past 3000 milliseconds. Okay. Specifically return the number of requests that have happened in the inclusive range, t minus 3000 to t. It is guaranteed that every call to ping uses a strictly larger value of t than the previous call. So this is a hint saying that let's say I get a time t2 in the first as my first argument. So the next time the t comes in, it's obviously greater than 2, right? And we can see it from the example, I guess. So the example is recent counter. Obviously it's a constructor. We initialize the counter to 0, then we have ping, 4 pings. So we see 100, 3001 and 3002, right? So it's clearly seen that this is coming in the incremental order, in the sense that the latest t value is greater than the previous value of t. Now, before jumping on to the question, let's look at the constraints. So for time t, it's between 1 to 10 to the power 4. Each test case will call ping with strictly increasing values of t. Okay. At most t to the power 4 calls to be made to ping. Okay. So I think this call to this method happens around once or twice maybe in the on the whole flow. And calls to ping, it says 10 to the power 4 calls are being made, right? So we need to optimize it, but we'll come to that part later. Before that, we'll discuss what values we might need. So uh, let's say I need an array to save all the ping values, right? And the maximum calls are t to the power 4. So array is fine, like we can hold 10 to the power 4 values in an array. So let me define a vector saying counters, and this should be pretty easy. I just reset everything, so I just clear out. Cool. And this should be done. Now let's figure out the ping part. um let me open my paint tool. So before jumping on to the approach, we see that ping values comes in a increase, like in a continuously increasing order, right? Which means that if I am at point, let's say 3, right, like the third position of ping, the value of t is for sure greater than the previous value of t. So in a way we can say it's a sorted order, right? So what approach comes to our mind when I say a sorted array? Obviously binary search, because it will take log of n time, and we see that there are 10 to the power 4 calls being made to the ping method. So intuitively we need to optimize it, and instead of each ping taking o of n time, if we can minimize it by o of log n, then it's a great optimization, right? And how do we do that? So as you can see, I have considered vector counters. Now let's say with every ping I just save it in the counter array, and at the same time I am supposed to return the value of numbers that come in that range, right? So we can see with the flow. Let me write down the numbers here first, and then we can look at the approach. Okay, so initially my number is 1, right? So we need to give the size, the number of time that come in this range. Sorry for my bad handwriting. I think I need to soon buy an iPad so that I can write it down. Yeah, now when I get 1, my value range would be between -299, right, comma 1, which is 1 right now. We got 1. When I get 100, it's gonna be between -2899 comma 100, right, which is 2, because 1 and 2 come between that. And then when I get 3001, my range is this, which is 3. Now when I get 3002, my range will be 2 comma 3002, which is 3, because 1 doesn't come in that range. Now how do we solve it? If we see, as soon as I get a value, I basically insert in the array, and then I do a binary search on it, right? So let's say I already have these 3 values in my array, and I get the 4th value, say 3002, right? Now when I do a binary search, saying, so my binary search will be, obviously this is the latest value, so that's my this bound, the outer bound. But what about the inner bound? Obviously I'll do t minus 3, so basically I'll do 3002, basically I'll do 3002 minus 3000, right, which is 2. So what I do here is I try to find a value which, if either I can find 2 or a value which is less than 2, right? So in this case I found this array element 0. So basically I get the index of 1 because that is less than 2, right? Another way would be I can actually find a value which is greater than 2. That actually greater than 2 would be a better approach. So I try to find a value either equal to 2 or greater than 2, right? So once I do find that, I have the index of that variable, that value, and this is basically 1, and my length of the vector is basically 4 minus 1. I get 3. That's my answer. So this is how I'm gonna apply my binary search. Let's jump onto the approach. So yeah, this method is done. I just come to the ping method. I'll do counters dot push underscore back t start define is equal to t minus, which is t minus 3000. That's my find value. While start is less than, n should be actually counters dot size minus. Okay. If index is equal to -1 right now, if what do I find? I'm trying to find find value, right? So if counters dot mid is find value, then index is equal to mid, and then I break. Else if my counters dot mid is greater than find value, I basically because it's on this side, so I need to go more left, so I do end, then end is equal to mid -1, else I do start is equal to mid Now there is a catch here. If in this basically is gonna give us the start value, right? If index stays at -1, if index equals to -1, we need to make index value equal to start plus 1, because what will happen here is if I am not able to find a value, my start is basically gonna point here. We can check that by a quick flow. Let's say I need to find 2, right? So my start will be 0, sorry, my start will be 0, end will be 3, right? Mid will be 3 plus 0 is 3 divided by 2, which is 1.5, which is 1. Now my 1 is what? um, Basically I can make it, yeah. So my 1 basically is 100, so 100 is greater than 2, that means I need to go more on left. I'll make my end as mid minus 1, so end becomes, so start is equal to 0, end becomes 1 now. Now I do 1 plus 0 divided by 2, which is equal to 0, right? Now my mid becomes 0. Now mid is, what do I say? In this case, mid would be mm, uh, 1, right? So 1 is greater less than 2. That means I need to go on right. So I do start mid plus 1. So my start becomes 1 now. And my end was obviously 0. Mid minus 1, sorry, end became 0, start became 0, right? Yeah, in this case I will break out. I'll increment the starts with this, and then I'll do return counters of size minus index. Let's run this and see if it works fine. Oops, spelling mistake. Okay, so now expected answer, your answer is 0, 1, 2. I think I'll do equal to here. Let's see. One, two, three, three. Okay, seems to be correct. Now let's submit this and see if it works fine. Awesome. So this is the approach I did. Overall time complexity will be off log n, and space complexity will be off n. Yeah. If you guys can think of any better approach, like to make this method to run in O of 1, that will be awesome. Please do comment below the video, and if you guys like this video, please hit thumbs up button and subscribe to my channel. Thanks everyone.